Welcome to Study Loop.
Let's find the area of the region under the given curve from x equals 1 to 2. So what they're asking for is the integral from 1 to 2 of this function. That'll just be the area under the curve from 1 to 2. And then we should do a partial fraction decomposition here to be able to evaluate this integral. So we can rewrite that denominator. Now this guy right here, this will not factor. If we just look at the discriminant, b squared minus 4ac will be negative. So this will not factor. So we can write this as a over x. That's what the author calls case 1. And then we have bx plus c for the quadratic, and this is what the author calls case 3. Let's go ahead and multiply this equation on both sides by this term down here. And then we can go ahead and combine terms. So let's pull out an x squared here. We have a plus b. Let's pull out an x. We just have cx and then a. So comparing coefficients on the left and the right, we see a plus b must be 0, c must be 0, a must be 1. So we end up with, let's write this out, a equals 1, c equals 0, and by this over here, b is negative 1. Let's just go ahead and plug in these values for a, b, and c into the right-hand side over here, and then we'll evaluate this expression. Let's go to the next page. After plugging in a, b, and c, there's our integral. So for the second one, we can go ahead and use a u sub here, x squared plus 1, and then du over 2. So that may help you with this integral. I won't actually use the u sub here. So the first integral, natural log. And then for the second, minus 1/2. You could see where the 1/2 is coming from. Natural log, x squared plus 1, 1 to 2. And then just go ahead and plug in the endpoints and simplify. Natural log 2, 1/2 ln 5 plus 1/2 ln 2. And then we have 3/2, combining those natural log of 2's. And there's our final answer.